All right. So as we have discussed the basic structure of information retrieval, so which will be consisting of three parts. Basically, the first part will be this document representation, how to make the raw text or raw documents into a form which can be searched faster. So later on, basically, we will be discussing this part together with this. The next part is basically transforming this information need via a query representation module to get a keyword query. This will be a little bit straightforward. We will not be discussing anything complicated here. In the next part, we will be the most important in this course is the retrieval model. This is the third part that we'll be discussing. Then this evaluation, and after the mid-sem, we will be discussing the feedback model. So this will be the first thing that we will be discussing. This is the second thing. This is the third thing, and this is the fourth. Today's discussion will be on this. So the way information retrieval basically works is based on an approach called bag of words approach. In this bag of words approach, what is done, or how this bag of words approach is developed or formed, basically given. So what is information retrieval? If we take one step backward to discuss the basics of the definition of information retrieval once again. So basically, given a set of documents, we need to find out the relevant documents given a query. So the first thing, that is, given a set of documents, which is also called corpus, in this IR, that those will be of unstructured nature. That is, there will be no specific structure, like the case of DBMS or RDBMS, relational databases. So basically, every document will be a collection of words, right? So given a document, it will be just a set of words. And similarly, the information need, which is transformed into a query, that will also be a set of words. So in this bag of words approach, what we will be doing is, we will be basically measuring the overlap between this bag of words and this bag of words. Based on the overlap, we will be giving certain score, or we will be computing the relevance of a given document given a query. So basically, as I said, a corpus is a set of documents, right? This terminology I will be using quite often. So basically, a corpus is a set of documents. So in the bag of words approach of IR, each document in this corpus will be represented as a terms or a set of terms. That is a collection of words like this, as I written here. So each document will be a set of terms, and given a query, this overlap will be basically indicative of how relevant the document is to the given query. So if I consider a simple Venn diagram, this will be basically the set of terms which will be common. Based on this common terms, we will be measuring the similarity, or we will be measuring the relevance of the document with the query. This is, as I said, is called the bag of words approach. Why bag of words approach? Because each document is represented as a set of bag of words, BOW. The terms are also represented as a bag of words, and we will just be measuring the overlap between them. Now, intentionally in this Venn diagram, I have kept the ellipse at the end of the document larger than the query, because as we know, or in most cases, the documents will be of larger size. That is, the document will be containing much more larger number of terms as compared to the query. For a simple news collection, the number of terms in a document will be, say, around approximately, say, 100. For a query, the number of terms will be approximately maximum from 3 terms to 5 terms. As we know, I mean, while searching on Google, we know we hardly give more terms than 5 or 6 terms maybe. So again, the task is, given a set of terms, that is the query, retrieve the documents containing those terms. This is basically the basics of this bag of words approach. So again, so what we need to do is, for this document representation, we need to represent each of this document as a list of keywords. Now this is basically the document representation that we will be discussing today. Basically, how to convert the documents into a list of keywords which will be making sense while performing this measurement of this overlap. So this is the part that we will be discussing. Given the document will be how to make a representation that can be easily looked up. This part will be discussed later on, and this part later on in the next half of this course. So the discussion of today is representing the documents. So this representation of document, or if we look at this diagram once again, from document to index, or a form from which we can look up fast, in between, as I said, there is a module called document representation. Now this document representation consists of mainly 2 aspects. First is basically the text processing, that is what terms to select in the document, and second is how to store those documents efficiently such that we can perform a retrieval or a fast lookup later on. So given a set of documents, our task in this document representation will be to store each of the document such that given some term as query, we can quickly find only those documents containing those query terms. And as I said, there will be 2 aspects in this document representation. First, given the document, we need to select. First is select which terms, selection of terms, select terms or words, and second is store those words. Okay, so these are the 2 aspects. The first is called text processing, which we'll be discussing today, and second is how to, after selecting a set of terms in this document, how to actually index it such that it can be looked up in a fast manner, such that we have selected these terms, how to actually store it in a way that we can perform retrieval quickly. So the first part, that is text processing, again consists of 3 different modules: term selection, term filtering, and linguistic processing. So in the term selection, there are 2 choices. One is controlled vocabulary and another is free text vocabulary. So from the name of the module, term selection, we can understand that the underlying task of this module is formulating a way following which we can select certain terms in the document. Right? There are 2 ways, as I said, controlled vocabulary and free text vocabulary. The controlled vocabulary, it is restricted and supervised, and for the free text vocabulary, it is basically selecting every term in the document. So now let's discuss about the controlled vocabulary, the first choice of selection of terms. This is an example, basically the index that we will be finding at the end of the book by Butcher, Clark and Cormack, the second book that I have given as a reference. This is the first page of that index, of that book, Butcher, Clark and Cormack. Here, like any other books as well, we will be finding or we will be observing certain terms and certain numbers. Basically, what this is actually indicating? This is indicating that abandonment is the word or a concept or a topic that is occurring in this page. Another, say, ADT or abstract data type. So here for this ADT, it is an exception. For this ADT, there is basically another another representation or another topic that is already covered to indicate the same ADT, which is abstract data type, which we'll be finding here. Similarly, say adaptive rank or adder rank or ad hoc task and so on. So basically, there are two components in this index. The first component is this, basically the topic, and the second component is this, which is basically the page number. So in this controlled vocabulary, the topics are chosen with human intelligence or human expertise. So while making this index, following a controlled vocabulary, what we'll be doing is, what the system will be doing is, basically it will be selecting certain topics or concepts, and in the while making the index, it will be making a list. Basically, you can consider a key value pair where the key will be the concept and the value will be the page number. So it is simply a dictionary with key value pairs where concept or topics is basically the key and this value is basically the page number, right? So here the controlled vocabulary in sum is basically a set of well-defined topics or concepts, the key part in this dictionary, right? And these are mostly assigned by humans with expertise. Because after looking at the entire document or entire book of this, let's consider this BCC book by the information retrieval book by Butcher, Cormack and Butcher, Clark and Cormack. While writing that book, the authors have indicated that these concepts are important. So later on, while reading the book, the readers will be finding it necessary to come back again and again into these concepts. That's why they have given this as the topic names or concept names, and they have indicated the corresponding page numbers as well, which is considered as a value. So the bottom line is these topics are basically assigned by the human being. Sometimes it can also be built up automatically, but the automatically built controlled vocabulary will not be as efficient as a human built controlled vocabulary. But of course, we can understand that automation, considering a large document or a large book, automation is the way to go ahead, because considering, say, a book of, say, 1,000 pages, if a human needs to annotate or needs to select all the concepts by their expertise, it will be too much tiresome. So we need some kind of an automation to actually make the things fast. But again, human expertise are the main thing. Will be much more efficient. But as I said, automation will also be needed. Basically, this automatically build up controlled vocabulary, we at the end of the at the end of the production of the vocabulary, we need certain human expertise there as well. So in case of controlled vocabulary, the documents will be represented by the topics that are covered in that document. Now, the obvious question that you can ask is which topics to select. So, given a document, which topics to select, that will be actually indicative of the concepts covered in that topic. This is a point that should be kept in mind while making a controlled vocabulary. Let's take a look at an example. So let's consider the Wikipedia page on Sachin Tendulkar. So if we go down to the page, we will be finding a category like this. Here you will be finding certain topic names. Basically, these are the categories, or basically the concepts which can be considered as the topics or concepts for a controlled vocabulary. Now note that there is certain very interesting observation here. You can see this topic, people named in the Pandora Papers, which is very recent. I think around a month or two back, I think in last October, Sachin's name came into the Pandora's paper. So if you look at the page, you will not be finding any mention of the Pandora Papers in the content, right? So there is no mention that Sachin's name came into the Pandora Papers list. The people of having, accounts in the foreign banks. This is basically the consisting of the Pandora Papers content. So in the content of this Wikipedia page on Sachin, you will not be finding any mention of that except in the controlled vocabulary here. So this is a nice observation. So basically, when the page is modified, some human editor must have considered or added this concept in the page of Sachin. Similarly, another example, let's say if we look at the Wikipedia page on Stuart Binney, we will be finding a similar controlled vocabulary, but as compared to the controlled vocabulary of Sachin, it will be much small, as we can understand, because Sachin is much more popular than Stuart Binney. So the point that I want to make here is, as the controlled vocabularies are human made, there can be some biases as well. Like, as Sachin is much more popular, that's why his controlled vocabulary is large in size. Also, there are certain topics which are not covered or can't actually be covered in Stuart Binney's Wikipedia page. That is also another factor. So in sum, the features of controlled vocabulary is it describes topics that are most central to the document. This category or topics or concepts, most of the cases will be unambiguous. Now, what is this ambiguity that I am talking about? That I'll be discussing in details later on during the progress in this course. For the time being, let's just define this ambiguity or unambiguity as the fact that will be discriminating one document from the other, discriminating one document from any other documents. From that point, we'll be discussing, or we'll be defining this ambiguity. We'll be discussing this ambiguity of terms and documents later on. For the controlled vocabulary, the topics do not need to appear explicitly in the text, as we have seen for the example with the Pandora Papers example on Sachin. And the relationship between the concepts facilitate non-query based navigation as well. Similar to the, again, I mean, we can consider the example on Pandora Papers. Like, if someone is asking, I mean, looking for people's name on Pandora Papers, they can actually look it up based on the controlled vocabulary concepts, although it is not actually appearing in the actual document. But there are certain issues as well of this controlled vocabulary. The first and foremost issue is it is developed by experts who know the data and the users. So we know we have to employ some basically some field experts who know the data quite well, which is expensive. And of course, if we, as it is human made, we can actually miss some important concepts which might be a little bit rare. And for the bag of words approach of information retrieval, basic term overlapping, that we have discussed, like we will be representing the document as a set of keywords and the query as a set of keywords, and we will be measuring the overlap between them. This kind of thing will not be applicable or will not actually properly will work in case of a controlled vocabulary. From that motivation, we'll be discussing the second option, which is free text vocabulary. In this free text vocabulary, what we'll be doing is, instead of representing the documents by the topics in the document, we'll be represent the documents by the terms in the document. Remember, in the controlled vocabulary, it was represent documents by the topics. So the obvious question is which terms to select. Again, considering the term selection, this sub module that we have started discussing. So in free text vocabulary, which terms to select? Shall we select the most descriptive or the most important terms? Or shall we select the most unambiguous terms? Again the term unambiguous is coming. You will be understanding the meaning in some time. Or whether shall we just select all the terms in the document? So which one to choose? So as suggested from the name, we will be selecting all the terms. So here the flexibility of this free text vocabulary representation or free text vocabulary term selection would be, it will be easier, or it will be actually possible to have a higher level conceptual overlap between the queries. So given a query with no direct, with no say, proximity based similarities, this can be actually done using free text vocabulary. Now, by the proximity based similarity computation, I am indicating the fact that given a query, say Q, which is say consisting of say Q1, Q2, Q3, we can actually have, if we are using this free text vocabulary representation, we can actually perform a search where we can specify whether Q1 will be near to Q2, or basically Q1 and Q2 will be just near to each other, and there can be say 3 other words at most in between Q2 and Q3. This kind of a retrieval is called proximity based search or proximity based retrieval. So using this kind of mechanism, if we select, or if we choose this free text vocabulary, we can perform a search similar to this proximity based search. Now, of course, in a document, in a simple document, we know all the terms are not equally important, right? Some terms will be more important than the others, like the, a, an, was, is. These terms will be basically less important than maybe some named entities, like someone's name, some country's name, etc. Now, this importance is important, or ways to understand which term is more important is actually crucial while performing the selection of the documents. Now, as we are selecting all the terms while representing the documents, this term importance is actually neglected. But later on, we can actually develop the retrieval model in such a way that this term importance will be taken care of by the retrieval model. So this will be discussed in this module when we will be discussing the retrieval model, basically how to select or how to understand which terms are more important than the other. So this is an example of a free text vocabulary, or basically a document. It is basically the document, basically the Julius Caesar written by Shakespeare. So as you can see, it is basically a set of terms. So you can see Act 1, Scene 1, so certain. So basically the total drama has been written. So now the obvious question, which is better, or which choice should we actually select? Whether we should select controlled vocabulary or free text vocabulary. So now, if we compare the controlled vocabulary with free text vocabulary from the point of view of cost, which one is higher? Can someone say? Cost of assigning index terms, that is the terms that we have selected. Which one is higher and which one is lower? Anyone?
Controlled vocabulary is higher.
Controlled vocabulary is higher, so free text vocabulary will be obviously lower because we are selecting everything. Now for the ambiguity of the index term, which will be ambiguous and which will be non-ambiguous or unambiguous. As for controlled vocabulary, we are particularly selecting certain topics which is central to the document. This will be obviously unambiguous. And as we are representing all the, or basically as we are selecting all the terms in the document in free text vocabulary, certain terms can appear in all the documents, such as, say, if we consider the say vocabulary or the data set containing all the cricket players of, say, India, we might be encountering the term World Cup or BCCI, sorry, World Cup or BCCI. Those terms will be occurring in all the documents, right? So basically this will be much more ambiguous. And considering the detail of representation, arbitrary level of representation can we make using controlled vocabulary? The answer is no. But arbitrary level of details we can actually represent in a free text vocabulary. Okay, so now, I mean, this was the comparison. Now, which one to actually select or which one to choose for our case? So actually both are almost equally effective, but there is a, I mean, it should be applied depending on the need. So if you are looking for, or if you are, making a search engine where the searching will be based on certain topics, you should be using controlled vocabulary. But in case you are developing a search engine which will be mostly working on keyword based search like Google search, you should be adapting free text vocabulary. As free text vocabulary is cheap and easy to implement because there is no intervention needed from the human expert, it is cheap and easy, and we will be using that one. Now let's consider a document. So this is basically the document, basically the text selected from the Wikipedia page of Gerard Shelton. As we have discussed in the first class, he is considered as the father of information retrieval. Now, this text processing, in this text processing module, given this document, so as we can see, so basically it is a set of terms. Now the obvious second choice is term filtering. Why? Because as we said, all terms will be not equal or equally important. We discussed that the importance of the term will be taken care of by the retrieval model, but obviously there are certain terms which is not at all important as we know, because such as say and, or say was, or say in, these terms obviously we can exclude, or this say a, of, these certain terms are obviously unimportant or uninformative, right? So considering a document like this, if we select all the terms, that is, if we use a free text vocabulary, the next obvious choice is how to filter those unimportant terms or uninformative terms. So the term filtering, the second part of this text processing, is actually consisting of three different modules or sub-modules. First is tokenization, then downcasing, and then stopword removal. So let's come to the first part, tokenization. So if we consider a document like this, so this is the document that we have seen in the slide. So it is basically a chunk of text, right? Gerard, A, full stop, space, quote, Jerry, space, Shelton, and so on and so forth. So basically it is a document which is basically a free flow text, right? Now, obviously, as we have seen or as we have discussed the bag of words approach of information retrieval, we will be computing the overlap between the terms in the document and the terms in the query, isn't it? Now, to have a one-to-one overlap, we should have certain mechanism such that there is a one-to-one match as well. Like if in the document there is Gerard, and if the query term is Gerard, it should be a match, right? But first of all, as I have told you, it is basically a string, a free flow text. First of all, we need to chop it up into individual words, like Gerard is a word, this can also be a word, this is another word, this is another word, and so on. So this process of basically splitting the entire string into different terms or different word, or informally or formally a set of tokens, the first step is considered, which is called the tokenization. It is a process to split a string or a stream. It can be considered as a stream as well. Stream into stream of string, you can say a stream into smaller string objects. Now the string objects will be basically the atomic unit of a document. So basically, as I said earlier, we had just a stream, right? Now the first part is to tokenize it such that the document becomes like word, 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 and so on and so forth. So basically this is the first part, that is tokenization. Tokenize the entire collection or entire document. So given a string, say friends, Romans, and countrymen, that the duty of tokenizer is to chop up, or this basically split up this entire string into different tokens. Now to make, given a text, to make basically a set of tokens, we can actually use NLTK. As I have said, we will be writing some codes as well. So I hope you can see my screen. This is a Jupyter notebook. So basically, this NLTK can be used to tokenize this document or this stream of text. So first of all, to use this NLTK, we need to import this. Now, if we perform this, if it is not actually installed, we will be getting an error like this. So I hope you know how to install this. Basically, you can perform a pip install NLTK, and it will be basically installing the NLTK package in your system. It is running the setup, so it is successfully installed. Now if I execute this, oops, extremely sorry. Oops. Really, I don't know why this is happening.
Maybe you have to restart the kernel.
No, I have actually restart and clear output. It was actually installed perfectly. So if we can see it is successfully installed NLTK. Okay, let me just give me a minute. I just need to check at my end a bit. No, it's actually pip installed, but I'm not sure why it's not. It's actually the same version.
If you are running this Jupyter notebook from from some server, then you
No,
can
no,
restart.
I'm not, I'm actually using, I mean, using my desktop.
Yeah, so on your desktop, you must have run a command to open the notebook.
Yeah, it's simple notebook.
Okay. Okay, then I don't.
So basically, this is the command that I have issued. So this is, I have
Yeah,
aliased
then
this notebook.
maybe if you restart this, right, kill this and run it
No,
again.
I don't think that will be actually. Okay, let's try that as well. You're saying, so this is the notebook. Nope. Uh, Really, I don't know why this is actually. Okay, let me, I hope you can see my screen. The command is -u, I think, in LTK. So I am using a Unix machine, that's why I need to give this. It's up to date. Let's also install it on pip3. Yeah, now it is actually getting downloaded, I think. Now if I perform this, yes. So basically the problem was, this was actually installing the NLTK in Python version 2. I'm glad that this error actually came into during the class. So now as you can see here, I have issued pip3 install. So basically pip3 is associated with Python version 3. So that's why after this, you can see import NLTK is actually working, right? Okay. Now let's come to the discussion that we are having. So basically, to use this tokenizer, what we need to do is we need to import this word tokenize module from this package. So let's do. Let's just write the code here. So let's just delete this. So I have explicitly not typing this. I want to show you why. So here, what I need to do is, oops, all right, yeah. So what I want to do is, this is the file that I want to actually tokenize. Okay, now this file is actually stored in a path. Let's just write it. The name of the path file is basically sholton.txt, and it is just above the present working directory. text equals to say fp dot read, and if I print text, it should be printing the sorry, if I print this text, it should be printing the entire content. Now what I need to do is I need to actually tokenize it. So after this, I need to tokenize it. Let's declare another variable, say tokens equals to word tokenize, which we should be importing beforehand as well from NLTK import word tokenize. Now, if I execute this, for the timing, let's exclude this. It will be giving me an error. The error is, from the error, you can actually look it up. What is the error? So you can see resource punct T not found. Please download it. So you need to perform this operation, which was actually given here. So we just need to perform this operation. Then we will be able to execute that code. Now, so now this punct T is actually being downloaded. So this punct T is basically a module which is actually containing these sub modules or these functions that are associated with this tokenization. Now, if I execute this, you can see it has been executed, right? Now, so now basically just call it tokens. Now expected this tokens is containing all the individual words in this file, in this shelton.txt file. Let's just check that. Print tokens, it will be basically a list. Now if I want to print the tokens in a better way, 40 in tokens, say print T comma say end, let's define it to say space. You can see this was the file and this was the tokenized file. You can see Gerard space a space, there is a space came into picture, then again full stop space. So every word has basically become a token here. All right. Now obvious issues can be what to do with this type of a string like PhD or USA or 3.1415. Shall we split it up? PH, then full stop D, U, see an individual token, S another token, A another token, 3 at one token, 1415 another token. What to do? Another issue is with the hyphen. Given a term, say post-COVID or non-English, I missed this here, this S here. So what to do? Shall we make it post-COVID together? If we make it post-COVID together, then considering a term overlap-based model, this will not be matched with a query term say COVID because the term is post-COVID. If we exclude this. Similarly, if we exclude this hyphen here, non-English will not be matching with English. These are certain issues with a simple tokenization based on just the space. Another issue is with the phrase. Hong Kong, we know it is a phrase, or United States of America. It is basically a four-termed phrase. United can be associated with many things. States can be associated with many things, right? Hong can be associated with so many things. Kong can be associated with so many other things, like King Kong. But this is actually a phrase. What shall we do? Shall we make it two different words? One is Hong and another is Kong. If we use a simple tokenization or a simple punctuation based tokenization, These are certain issues that we will be facing. Another type of issue is with the hyphen. O'Connor. It's a name of certain person, mostly Irish. So what to do with this hyphen here? Shall we make O one word and Connor one word? Or shall we keep it together? These are certain issues we need to keep in mind while for applying this kind of tokenization approach. Another issue can be with non-English text. If we look at the Mendelian representation of information retrieval, it looks something like this, where it is, as we can see, it is consisting of 4 different, I don't know whether they are called words or not, but individually this first part means letter, the second means message, the third means check, and the fourth means search. But together they are actually information retrieval, 2 words in English. This is an example of a German text, which is that the English translation of which is basically life insurance company employee, which is a single word. So what to do with this kind of an issue, situation? So basically language detection is actually necessary step that we should be applying before tokenization. But in this course, we will be completely focusing on English. So the language detection part will not be needed for this course. But in a real life scenario, as you can see in these 2 examples, we should be applying language detection, and there should be some tokenization approaches based on the corresponding language. Now, after performing the tokenization, as we have said, if the word that is appearing in the document is Gerard, and the term that the user is issuing is basically Gerard with small g, it will not be getting a match. So we need to downcase all the words. It is also called case folding. So from this set of tokens, after applying this downcasing or a linguistic module, we should be getting the individual words like this. Now, to actually make the tokenization and downcasing all together, we can simply apply this to lower or this dot lower function on the text. Let's try that. So here, so basically what we will be doing is we will be applying text equals to text dot lower. So basically text was containing the entire file, right? Now after applying this is again the entire file, but all words are converted into the downcase or the lowercase. Now after applying this, we are expected to get a set of tokens, which will be basically all the words for which all the letters are in small case or in lowercase. As you can see, all the words has become in lowercase. Another simple way of doing the same thing using shell command is this, where we are replacing all upper characters into lower characters. Here this should be the file name that we need to convert, and this will be the output file name that will be written after executing this command. Now there can be some issues with downcasing as well. Like, let's consider an example. Quit beating around the bush, and as compared to former President George Bush. If we convert all the letters in lowercase, this push and this push, although with our human intelligence we know this is something and this is something else, but after downcasing, we might be getting we will be getting the same representation, which will be small bush, and there can be some mismatch between the queries and the document while retrieval. Another example is, say, he lives in US and it has been done by us. Here us and us or US will be same. What happens after cracking cat? Or the cat was coming after me. So what are the alternatives of, overcoming this kind of an issue? So a basic heuristics is make some tokens lowercase based on a simple heuristics, which is lowercase words at the beginning of a sentence, like here this is of course not also 100% effective, but most of the cases it will be effective. Lowercase words at the beginning of the sentence, all words occurring in a title that is all uppercase. So we know that sometime to specify shouting in our messages, we used to write all letters in capital. So in this type of cases, we should be converting all the letters in lowercase, and in which most or all of the words are capitalized. This is also a case where we should be converting some of the we'll be converting all the letters into lowercase. So this is a simple heuristic. Mid-sentence capitalization should be left as capitalized like this. Former President George Bush. We should be keeping it as it is. Now, lowercasing everything is still the most practical solution, for which we need not apply any heuristic, and we can simply get the desired output. Now, considering the raw text, after applying the tokenization and downcasing, this file has become this, right? Now, if we consider a snippet from that document, from that text, the raw text was Shelton was perhaps most well known for developing blah 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 blah. After downcasing and tokenization, it has become Shelton with small s. Everything has become in downcase, right? Information I, R, all are in downcase. But you can see, or we can understand, that this was most, for, the, now, and for. These are actually not very informative words. We can simply ignore them. With that motivation, so basically these are called the stop words, and we can actually ignore them as they are not very useful while computing or measuring the term overlap while doing the retrieval. So with that motivation, the third module of this term filtering came into picture, which is stop word removal. So to simply remove a stop word, again, we can actually use basically NLTK for that. So what we'll be doing is we'll be writing the same thing. So here you can see there are so many stop words. So stop word removal. So basically what we'll be doing is for that we will be writing from again NLTK NLTK.corpus import stop words. Now after executing this again, okay, we are not getting an error, thank God. Then stop list or stop word list equals to stop words dot words in, say, English. Now here we'll be getting a similar error, so we need to execute this once again, which will be basically downloading the stop words in the stop word list of English. Now after executing this, we will be getting a list of words which are considered in the English stop word. These are certain stop words that are given by the NLTK, right? Now after that, what we can do is we can simply write a code similar to this. So basically filtered, I have written one list comprehension command here. So w.lower then say for the words in W in tokens, if W dot is alnum, that is if it is alphanumeric, this command is basically will be excluding the words which are basically some certain comma, full stop. So this will be basically excluding them. And W dot lower, which is basically we can not in stop words or stop list. After executing this, now if I apply or if I print the content similar to this, we will be getting, oops, forgot to copy it. So in this case, it will be basically filtered. Sorry, filtered. We will be getting basically the important words from this document. This is called stop word removal. Okay. Now there are also some possible issues with stop word removal as well, such as this famous book by Vannevar Bush, which was written in 1946, I think. The name of the book was As You May Think. If we apply a stop word removal on this, it will be removing this and this. To be or not to be, that's the question. The famous quote from Shakespeare's work. It will be basically becoming an empty string because all the 6 words are stop words. So if we actually are basically using the Shakespeare's work, specifically say Hamlet, we will be getting a empty list if this word is given. I was not present at the murder spot. Now this is a very interesting example. If we apply a stop word removal, what we will be ending up with is basically I present murder spot. On removing this not, it is actually removing or basically changing the whole aspect of the statement. So these are certain issues with stop word removal. So there can be possible 3 possible steps that we can consider. First is extensive stop word removal, that is having a large set of list of stop words, maybe 200 to 300 words, following which we can actually encounter this kind of an issue. Second is a restrictive stop word removal containing say 10 or 20 words. And the third is basically no stop word removal. Now the third approach is basically taken by certain web search engines, but we will be adapting somewhere some approaches near this extensive and this restrictive stop word removal approaches. In our while we'll be writing the codes, we'll be using a moderately large set of stop words, maybe having say 100 stop words. Because stop words can actually play certain bad parts while performing feedback based relevance. So we will be discussing this later on. So this was the today's class. So in the next class, so we discussed this. In the next class, we'll be discussing the linguistic processing, basically stemming and stemming and lemmatization. Then we'll be starting with the indexing. Thanks a lot. Any question?